Okay, in the previous problem, we identified that the copper sulfate was the limiting reagent, the sodium phosphate was the excess reagent, and that we could produce 7.95 grams of copper sulfate. Now we have three other questions we can ask. What is the concentration of the spectator ions, the sodium and the sulfate? And what is the concentration of the phosphate, which came from the excess reagent, okay? So let's very quickly review how we calculated the limiting reagent. We took 10 grams divided by 1.5961 grams per mole, and that gave us 0.0627 moles. We took the molarity times the volume, that gave us 0.05 moles. Then we divided this by 3. We divided this by 2. This divided by 3 was 0.0209. This divided by 2 is 0.025. So this was smaller, so this was the excess reagent. Now we've got to remember that in a double displacement reaction, if one of the products is a spectator ion, its ions are not involved in the reaction, and really we do not have copper sulfate or sodium phosphate floating around. We have copper floating around, sulfate floating around, sodium floating around, and phosphate floating around. So let's look at the net ionic equation, okay? So the net ionic equation would be 3Cu plus 2 plus 2PO4 minus 3, and these are both aqueous, forming Cu3PO4 2 as a solid. And this got consumed, and there's excess of this. How much excess is there? Okay, so the excess, PO4 minus 3, would be equal to the PO4 minus 3 initial, how much we started with, which minus the PO4 minus 3 consumed by the complete consumption of the limiting reagent. Now once we find the moles of the PO4 minus 3, we can then divide into the volume and come up with the concentration, okay? So the next thing we need to notice is that for every mole of copper sulfate, there's only 1 mole of sulfate. For every mole of sodium phosphate, there's only 1 mole of sodium phosphate. That is, Na3PO4 breaks up into 4 ions, 3Na plus PO4 minus 3. So the sodium concentration is 3 times this value. The phosphate concentration is this value. Taking that into consideration, I can say that the PO4 minus 3 initial is 0.05 molar. So my PO4 minus 3 initial is the same as the sodium PO4 so I can now go 0.05 moles. Now, the moles of the phosphate consumed. If I started with 0.0627 moles of copper sulfate, just as in over there, every mole of this has 1 of this and 1 of this. So the sulfate, the copper concentration is also 0.0627. So minus, let me put moles PO4 minus 3, and I'll put the I there just so we know that's the initial. Minus 0.0627 moles Cu plus 2. Now I come over to my equation, okay, and for every 3 moles Cu plus 2, I make 2 moles phosphate. So I have 3 moles Cu plus 2 for every 2 moles PO4 minus 3, okay, and this is the amount consumed. If I do my math, this becomes 0.0418 moles consumed, and when I take my 0.05, subtract the 0.048, I have 0.0082 moles of phosphate excess, okay? Now, the concentration is this moles in the volume. Since my solution had 0.5 liters, the molarity of the PO4 minus 3 is the 0.00, getting hard to write down here, 82 moles PO4 minus 3, over 0.5 liters, which is equal to 0.0164 moles per liter, which is equal to 0.0164 molar. Okay? So in review, my solution consumed up all of the limiting reagent, the copper, and produced 7.95 grams of copper 2 phosphate, which we discussed earlier. And we had some excess phosphate. So I calculated the initial phosphate minus that consumed through the complete consumption of the limiting reagent, divided into the volume, and my final solution is 0.0164 molar in PO4 minus 3. Thank you. Okay, did it take it?